Hey guys, this is week 4. This is going to be our last week of looking at the sine and the cosine equations. Next week we'll move on. And this week is very similar to last week with the regressions. We're going to read each scenario, and all we need to come up with is a maximum and a minimum. And then from that max and min, we should be able to answer everything about this question. A Ferris wheel. It says, as you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position below in the figure. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it will take 3 seconds to reach the top, 43 feet above the ground, and that the wheel makes a revolution every 8 seconds. The diameter of the wheel is 40 feet. So it wants us to sketch this, and again, I want to see at least one period, but before we sketch, we need to come up with some points. So looking at things that we know here, I need to find this point because that's going to be my maximum height, and this point will be my minimum height from the ground. Okay, so it tells us right here it will take 3 seconds to reach the top, and you're 43 feet above the ground. So we know that point right there is 343. And so we know one of our maximums is 343. Now, we need to find this point. Well, it told me that the wheel makes a revolution every 8 seconds. Every 8 seconds. Well, from here to here is half of a revolution. So this is going to be 4 seconds later when it reaches this bottom point. So 4 seconds later would be 7 seconds. Now, we need a value here. How far from the ground is this? Well, this is where the diameter comes into play. It tells me that the diameter, which is from the very top to the very bottom of the circle, is 40 feet. So if it is only 40 feet, that means this has to be 3 feet off the ground. So the distance from 3 to 43 is your 40 feet. Okay, so your minimum is 7.3. So when I go plot this, I know I have a point at 3. 43 is the max, so I'm going to put that up at the top of my graph. I know I have a minimum 7 seconds later, and it is at a height of 3. Let's see, feet. Now, I need another maximum over here. I just need to find this value. Well, this distance from 3 to 7 is 4, so add 4 again, and I get 11. So my other maximum would be at 11:43, which makes sense because from 3 to 11 is 8 seconds, and remember that's what one full revolution is. Now we need these middle points here. So I know I'm going to have a point right in between 3 and 7 and right in between 7 and 11, and it will be right in between those two values as well. So we need to find them. And remember, they're not always perfect whole numbers. So when I add 3 and 7, I get 10. Divide that by 2, that is 5. Add those up, 18 divided by 2 is 9. Now the same thing here. When I add 43 and 3, I get 46. Divide that by 2, I get, let's see, 23. Okay, so there's the middle of my graph. There's one perfect period, basically. If you wanted to come down and put a point at 1, you could, but it's not necessary. Okay, so we have a graph. Let's go ahead and write our midpoints here. We had 523 and we had 923. All right. It says, what is the lowest you go as the Ferris wheel turns, and why is this number greater than 0? So the lowest our Ferris wheel goes is right here. It happens at 7 seconds, but we are 3 feet above the ground. Now, why is this number greater than 0? Well, this is where a little bit of street smarts and common sense comes into play. It has to be off the ground, otherwise you're the bottom of the cart or your legs or whatever is going to drag the ground. So that Ferris wheel has to be above the ground. Part C, we need an equation. And we want a sine equation and we want a cosine equation. So let's kind of go through and look at some different things that we need to know. We know the amplitude is going to be this distance that it varies. So 43 minus 23 would be 20, or I could do 23 minus 3, which would still be 20. We need to talk about, let's see, the vertical shift, or the middle of the graph is up at 23. So we're going to have a plus 23 on the end of our graphs. To find the b value, we need to know the period. Well, we've already talked about the period is 8 seconds. So I'm going to take 2 pi over b, set it equal to 8 over 1, and do some cross multiplying. So I get 8b equals 2 pi. So when I divide by 8, b has to be pi over 4. All right, so when we start looking at the phase shift, we need to look at each graph. For cosine, we want the closest min or max. Well, that's going to be this point right here. So for cosine, we need to shift forward, so minus 3. And we're going to take the b, which is pi over 4, and we need to distribute that. So it's also a maximum. So make sure when you put your a down, it's going to be a positive 20. Make sure also you have your y equals. I had some people turn in their papers last week with no y equals, so make sure we fix that this week. So it'd be 20 cosine. Now we distribute this pi over 4, so pi over 4x minus 3 pi over 4. And then don't forget we need our plus 23 at the end of the equation. So there's that one. For sine, then, we're looking for the nearest midpoint. Well, the nearest midpoint would be right here. So now we're moving forward 5. So it's very similar to the last one, except now we're moving forward 5. From this point, also, we need to note that we're going down. So the 20 needs to be negative 20. Sine of pi over 4x minus 5 pi over 4 plus 23. So there's that one. All right, before I move on, I'm going to go check this in the calculator. So I have my equations put in. I'm going to go fix my window, and let's make the window match perfectly. On the x-axis, I'm going to go ahead and start at 0 so that we can see where that y-axis would be. And we need to go to at least 11. If you want to go to 12, that's fine. X scale, we can count by ones. It does not matter. The y-min, I'm going to start at 0. And the graph tops out at 43. If you want to go a little bit above that, that's fine. And then let's go to graph, and let's just see. And we will. Our graph is not going to start till this point right here. But yes, there's still going to be part of the graph right here. It's not necessarily on your paper. If you want to add it, that is fine. But the main goal here, make sure they match up. And they do. So we're good. All right, and if you want to hit trace and check those points that we have, we said at 3 we needed to be at 43, 11 we need to be up there. That minimum we said would happen at 7. The midpoints are at 5:23, so we've checked that one. The other one is at 9:23. So make sure you're hitting trace and you're checking those points. All right, moving on to the next one, then it says use one of your equations. Well, honestly, it doesn't matter because the equations are the same. They give you the same graph. So use your equations to predict the height above the ground after 6 seconds, 9 seconds, 4 1/3 seconds, or 0 seconds. Okay, so these are all seconds. These are times. So we're plugging all of these values in for x. So the only place I can do that would be when hitting trace. So we would have, we've already hit trace. I can hit it again. So there's your answer for 6 seconds, for 9 seconds. Now, with 4 1/3, don't put 4.3 because that's not 4 1/3. So what I would do on 4 1/3 is make 4 1/3 improper. So I know 3 is going to stay on the bottom, and then when I multiply and add, you should get 13/3. And so that's going to be the best answer to type in there. So for 13/3, and then there's your answer for that one. So 33 feet. And then the last one is 0. So there's all of your answers for that one. So that's not too difficult. It's very similar to last week. So let's go back and look at question 2 real fast. It's a spring. So we have a spring bouncing up and down. So it's going to keep going up and down and up and down. So it's going to have that same sine or cosine pattern. It says a weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reads 0.3 seconds, the weight reaches the high point of 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. So again, there's a lot to read there, but as you're reading it, I would start underlining things that are important. I see it reads through 0.3 seconds, and it's going to have a high point. So there's a maximum. So we have a max at 0.3, 60. And then it also says the next, low point is 40 centimeters. So this is a low point. And this occurs at 1.8 seconds. Well, seconds has to come first. So that's all we need. So we have, which one of these would come first? This maximum 0.3 would come first. So I'm going to put 0.3 and the max is 60. We have, this would be 1.8 and the minimum is 40. So we need another point over here up at 60. We just need to figure out what this value is. So I'm going to look at the distance between these. If I take 1.8 minus 0.3 and subtract, I get 1.5. So I need to take 1.8 plus 1.5 and I get 3.3. So there's my next max. So 3.3, 60. All right, so now I need a middle point there, a middle point there, and then the middle of 40 and 60 would be 50, so I've got that one. So to find this middle value, I'm going to add up 0.3, 1.8, divide by 2, and I get 1.05. When I average 1.8 and 3.3 here, I get 2.55. So those are my middle values. And there's my graph. Okay. So this happens at 1.05, 50, and at 2.55, 50. All right, so now we start writing our equations. Again, let's talk about the things that are going to be important between the two. We know the amplitude is 10 because from the middle of the graph, I'm varying 10 in each direction. I know the middle of my graph is 50, so I'm going to have a plus 50 on the end of my equations. The period, I'm looking at the distance from the maximum to the maximum. So if this is 0.3, this is 3.3, the difference there would be 3. So remember, to find the b, I'm going to, take 2 pi over 3, set it equal to 3 over 1, and I'm going to cross multiply. And when I divide by 3, my b is right there. My b is 2 pi over 3. All right, so again, looking at cosine, we want the nearest max or min. Well, this is a maximum. So we want to shift forward. I'm going to make that a fraction and call that 3/10. And remember, we have our 2 pi over 3 out here that we're going to distribute. And it's a maximum, so I'm going to have y equals positive 10 cosine. Now when we distribute, we'll get 2 pi over 3x minus, now when I distribute to the second part, those 3's are going to cancel, and you're going to have a 2 pi over 10, which reduces to pi over 5. And then don't forget your plus 50 on the end of that. Okay, now for sine, we're looking at the middle point. So now we're shifted forward 1.05. Now 1.05 I know is 1 and 5/100ths. And so you can reduce that. That would be 1 and 1/20th, I believe. And so as a fraction, improper, that'd be 21 over 20. Okay. And so right here, I'm going to take my 2 pi over 3. and I'm going to distribute that to x minus 21/20. Okay? It is going down from this point, so at the beginning I need to have a negative 10 because it's going down. When I distribute, I'm going to have 2 pi over 3x minus, now more reducing can happen here. The 21 and the 3 will cancel, so I would basically have, I'm going to write it down here just so we can see it a little bit better. 3 is going to go away, 21, that's a 20. 21 is going to become a 7, 2 is going to go away, 20 divided by 2 is 10. So you are left with 7 pi over 10. And then we have our plus 50. And again, I would make sure at this point you're going and checking it in your calculator. I would make your x min 0, x max 3.3, y min 0, y max 60. And then go graph everything and make sure they match up, that they're the same line. And then it says predict the distance from the floor when the stopwatch reads 17.2 seconds. Now, this is a time. So since it's a time, I'm going to trace it at that value. Here's a problem that you might run into. If 17.2 seconds is outside of your window, which it would be according to this graph, you need to change your x max and make it bigger than 17.2. Once that value is in your window, then you can hit trace and type in that value. And when you do that, you get 43.3 centimeters. All right, and then it says, what is the distance from the floor when you started your stopwatch? So when you started your stopwatch, that's when the time equals 0, which we're using x for that. So that I'm going to hit trace, type in when x equals 0, and it's going to give us basically, if this were to come down, it's going to give us that y-intercept. So it's going to give us this value right here. And it actually ends up being 58.09 centimeters. So make sure you guys have your units with these as well. So that's it. It's very similar again to last week's. And next week we will move on. Guys, if you have any questions at all, we will have our Google Meet again at Wednesday at 12:30. That's a great time to answer questions, and then you guys can email me anytime.